So now if I do explain analyze, select count star from grades parts where G equal 30. So now which table is gonna, where are we gonna hit, guys? We should hit the first partition, right? Let's check this out. So we says, hey, index scan only on which partition? G003G index on this partition. So we only hit one partition, right? And it took us 1 second to query. Still, yeah, this is not much compared to what? To the original table, right? The original table, you're gonna see, guys, it's the same thing. Hussein, you say that partition are great and we're gonna be faster. Not really. If you think about it, my Mac here is at what, 16 RAM, 16 GB of RAM. And the Docker container doesn't have a limit, I believe. I didn't have a limit. So it's going to use all the memory it needs. And that is the same identical queries. There is no bounding limit. There's no memory bound. There's no IO bound. If I limited the container to like a 500 megs, right? And the index was so large such that it doesn't fit in memory, then you're going to start seeing the difference hitting the huge index versus hitting the smaller index, guys. But now you don't see it, guys. So guys, how about we show you the sizes of these indexes now compared to what we have here. So hopefully I remember the query. Select relational. All right, so the function called PG relation size, that's a function that gives you the size of the relation, and that's an index or table or anything. It's going to OID, that's object ID. And then I'm going to also select the relation name. And from PG class, that's the table, order by exactly the same thing. Relation size OID descending, because I want the biggest ones first. All right. So you can see, guys, this is our original table, grades original. And it's around what? That's bytes, right? So you divide it by 10,000, 100,000, so you get this in megabyte. So around 362 megabyte, which is not big, right? But multiply that, for instead of 10 million, make it 100 million, 500 million, then you can start see this is increased. And these are the other partition. That's the oh my God. This is the rest of my partitions, partition 1, partition 2, all the partitions, and these are the sizes. Still not something that large. This is also 126 megabyte. That's apparently, this is 0 to 35 is very popular grade. That's bad. Everybody's failing. So the original index is around what, 69 megabyte. That's the big large index, 69 megabytes. Guys, 69 megabytes is nothing for my Mac. That's why we didn't see a difference. But increase the size of the rows will increase the number of the index, and that will slow things down even more. So, but look at this, guys. The individual indexes are way smaller than the large indexes. So the individual index, which is the 035, right? That's the first partition, is around only 24 megabytes. So it's like what? 3 times smaller. And obviously querying this index is way faster than querying this index, right? The size and the index matter, where is it list, and the scatter indexes and all that stuff, guys. So it really, really, really matter, guys, this little bit of information. And then the final thing I'm going to show here is there's a feature in Postgres. I want you to make sure that it's on. And it's called, let me get it right here. It's called enable partition pruning, right? Let's see what's the value of that. Enable partition pruning. The value of whenever partition and pruning is on, and you want this on, guys, by default. If it's off, well, how about I show you what happened if this is off? All right, so let's set this to off. If this is off and I do explain analyze, we don't really need to analyze, just explain. Select count star from grades parts, the partition table, where G equal 30. So which partition this is supposed to hit partition 1, but nope. Look at this stuff. It hit partition 1, it hit partition 2, it hit partition 3, and it hit partition 4. And I have no idea why do we have this option to begin with. Maybe it's like a safeguard somewhere in Postgres, but this is dangerous. So if this is off, you just wasted. This is the whole partition is useless because you hit all the 4 indexes, all the 4 partitions. Compare this to set it to on, execute the same query again, and look at this, we only hit the 1 partition. So make sure that this thing, that partition pruning, is always enabled. Otherwise, you will not take advantage of this thing, guys.